Assalamu alaikum students. Today we are going to look at pressure. Have you asked why at home peeling is done using a knife, not an axe? Now, today in this lesson we will be able to, first of all, define pressure and state its SI units, calculate pressure exerted by solids, explain the application of pressure on solids, and we'll be able to answer the question above. To start with, let's first understand the concept of pressure. Pressure is a force acting per unit area, or you can say force acting on an area of 1 meter squared. In summary, P, which is pressure in pascals, is equal to force in newtons divided by area in meters squared. Therefore, the SI unit of pressure will be pascals or newtons per meter squared. Pressure and area are related in such a way that, first of all, pressure depends on two factors, that is, forces acting and area of the surface. Pressure increases as area decreases. For example, in the figure, you can see that a flat shoe and a high heel shoe. A flat shoe exerts a small pressure because of the big area, and a high heel shoe exerts a big pressure because of the small area. Therefore, if we are to calculate pressure, let's have a simple example. A force of 10 newtons acts on an area of 2 meters squared. Calculate the pressure exerted. To handle this question, we have a force which is 100 newtons and an area of 2 meters squared. From the formula, pressure is equal to force over area. Substituting in, we'll have pressure to equal to 100 newtons divided by 2 meters squared. Pressing on my calculator, this will give us 50 newtons per meter squared. Let's have a look at another example. Calculate the pressure exerted by a car of mass 1,200 kilograms. An area of contact between the road and each of the 4 tires is 50 centimeters squared. To handle such a question, we will first of all summarize. We are given mass of 1,200 kilograms. An area of each tire is 50 centimeters squared. Therefore, the force will equal to the weight of the car, which is mass times gravity, where gravity is 10 meters per second squared. Therefore, our force will be 1,200 times 10, which gives us 12,000 newtons. Therefore, the area of contact A is equal to the number of tires, which are 4 for the car, times the area of each tire, which is 50 centimeter squared. This will give us 200 centimeters squared, which is also 0.02 meters squared when we convert it. Therefore, pressure is given by force over area, whereby the force is 1,200 divided by 0.02, which will give us 600,000 newtons per meter squared. Maximum and minimum pressure. In solids, pressure depends on area, as we have seen before. When surface area is small, the pressure is large or high or maximum. When surface area is big, the pressure is small or low, what you can call minimum. Let's have some applications involving high pressure. A sharp knife has a very small surface area on its cutting edge. Therefore, it exerts high pressure. When you look at the nails and the needles and pins, they have small area at the surfaces, which means when you apply a force, there will be high pressure exerted, which enables the sharp nail to enter into a wood. When you look at football shoes, they have what you call teeth, but they are called studs. So these studs are very small so as to create a small area which makes the pressure to be big, making it easier for them to sink in the ground, more so during the rainy season. That's why the footballers are able to keep steady. Then applications involving low pressure. Skis, people who do skating in countries where we have Icelands, in those countries, they have large areas which reduce on the pressure on the snow so that they don't sink into the pressure. A tractor, it has bigger tires so as to reduce on the pressure. Hey, by the way, the backpacks that we normally use to put in our books, they have their belts a little bigger, what you call the pads. This helps to reduce on the pressure that is exerted on your shoulder when you are carrying the bag. Let's have a simple calculation on maximum and minimum pressure. A brick of mass 5 kilograms measures 20 centimeter, 10 centimeter, 55 centimeter. They want us to calculate the least or minimum pressure and then the maximum pressure it exerts. Let's have a brick of this kind. We can see that the measurements are in the order of length times width times height. Therefore, the force will be the mass of the brick, which is 5 times the gravity, which is 10, giving us 50 newtons. Then maximum area is equal to length times width, which is equal to 20 times 10, which is 200, which when converted to meters will give us 0.02 meters squared. In other words, it is better we use bigger values to calculate the maximum area. Therefore, the pressure will be minimum whenever area is maximum. Therefore, minimum pressure will equal to force over maximum area, which is equal to 50 divided by 0.02 meters squared, which will give us 2,500 newtons per meter squared. Roman 2, they want us to calculate minimum area, which is given by width times height, which means we need to take the smallest values. So therefore, we see that 10 and 5 are small in this case, giving us 50, which is 0.05 meter squared. Therefore, pressure is maximum whenever area is minimum. So pressure will be given as maximum pressure will equal to force over minimum area, which is equal to 50 divided by 0.05, which gives us 10,000 newtons per meter squared. For that case, we can now try to look at these questions and we see how we can handle them. Thank you. Remember to subscribe on my channel. Have